Well, hello friends. Welcome back to the program. It's been a while, but I miss making videos, so let's make a video. Today we are going to work on Ladybird, and I've been testing with Shopify.com a lot recently because they use all kinds of modern CSS and JavaScript features and stuff, and it's just really good at making our lives difficult as a browser, which makes it a good test page. And we've been making some headway. Like the layout is coming together slowly, but we are missing like this big animated promo thing here. And they have this interactive 3D globe thing that we don't support yet. We just get a static globe. And there are various visual issues, like this girl here looks a bit squished. But today I wanted to work on this thing right here. So we have this little, the help you need it when you need it section. If I show you that over here in Chromium, you'll see that, that it's supposed to be a 2x2 grid kind of layout, but we are doing a 1x4 for some reason. So I wanted to implement support for what they're doing here. So I did scout ahead, so I have some clue of what they're doing, and it looks like my DevTools look a little borked. Let me see if I can open this in Firefox instead. I think something with the latest Chromium is a bit borked with my GPU for some reason. So DevTools window is translucent sometimes. Let's see. Yeah, this looks a lot nicer. So if we look at what they have going here, this is a Flexbox layout with 4 flex items. So there are 1, 2, 3, 4, right? And they are wrapping because they're all immediate children of the flex container. So it's a multi-line flex layout. Wrapping here, as you can see. And the thing that was so weird was, right here. The flex basis of the items is a calc value. And I think that's why we're falling apart, because we don't support calc values in flex bases. At least I think that's what the problem is. That's as far as my investigation up ahead went. But the first thing we're going to do now is we're just going to make a test page here. So we'll call it calc flexbases.html. And then we are going to try to recreate the problem if we can. And then we will have a much simplified test case to work with. We don't have to load Shopify.com every time, because that takes a moment and it's not ideal for quick testing. So we're just going to make, I like to do this, first of all, just to give everything on the page a border, just to helps me visualize what we're doing. And then we're going to make a flex container. We'll call it flexbox. And it had flex wrap. And maybe we'll give it a little background, make it pink. And then we will have flex item. You know what? We'll call it flex container, just for ultra clarity. And the flex items are going to have flex basis, calc, something or other, 50% minus var gutter /2. So let's see if it's enough to just do that. I wonder if we would simplify that, because we do the simplification pass of calc values. So It might actually be simplified before it gets to layout, but we'll see. We'll make the background orange because I like orange on pink when I make layout tests for some reason. And then let's set this thing up. So flex container, and we will make some flex items here. I guess we can do them like this. Okay, so there we go. And calc flex basis. Okay, so that's not super exciting. And it already feels wrong. Yeah, so here's Firefox accurately giving them 50% flex basis. Flex basis is the main axis preferred size, I guess, if you don't say anything else. So it's the, in this row flex layout, it will be the width normally. But if we switch to a column flex box, then it will be the height instead. So there we actually accidentally do a better job, but that's just accidental. So let's see. So that's a 50%, but I guess the reason that they are not 2 by 2 is because we add the border. So if we didn't do that, then there would 50% would be enough. But because of the 50%, we would have to do like box sizing border box. Does that work? It does. Okay, so we should support this. So here is our basic layout, and this is what we do with that layout. Currently, wait, they have a width also on the thing? Am I seeing this right? Wait, am I looking in the right place now? Let me see. Where were we? The help you need when you need it. Let me just make sure that I got this right here. So these items, so yeah, so it has a flex basis with a calc value, but it also has width, 80 viewport width units. So maybe we should set that as well, just to make sure that we are recreating the same conditions. Okay, yeah, then we get that behavior instead. So this is 80% of the viewport. But of course in Firefox it doesn't matter because flex basis takes precedence over width, as it should, if I recall correctly. So okay, well here is at least our little test case. Maybe we'll make the font size a little bit bigger just for funsies. That did not make it bigger. There we go. Maybe even a little bigger. All right. Ooh, there's a little unaesthetic, like they're not lining up perfectly because of subpixel snapping here. I think we are not doing a super perfect job with alignment for things like that. So maybe if we give these a height, it will be consistent at least. So if we do that, then yeah, then there will be integer heights. And then we don't have to look at these ugly gaps between some of them. Okay. There is our test. Great. So what do we need to do now? Well, step A is go to the CSS Flexbox specification. TR CSS Flexbox 1. Take me to it. Here we go. Maybe we'll use the editor's draft. Oh, I thought that was going to be dark. Okay, let's look at it in Firefox too, because at least then it's nice and dark and comfy. So flex basis. Right, so the flex basis property sets the flex basis. It accepts the same values as the width and height property plus content. Right, so it can be either the same value that you would put in a width or height property, or it can be content. For all values other than auto and content, flex basis is resolved the same way as width and horizontal writing modes, except that if a value would resolve to auto for width, it instead resolves to content for flex basis. Yada, yada, yada. Sure. Okay, so I think the problem is going to be in our flex formatting context. Pretty sure that I've even seen a fix me about this. So flex basis. So where we are determining the used flex basis for an item, which, let's see. So if flex basis is auto, then we're doing what that thing was saying. When specified on a flex item, the auto retrieves the value of the main size property as the used flex basis. If that value is itself auto, then the used value is content. Okay, so if you say flex basis auto, which I guess is the initial value of flex basis, yep, then it just becomes width or height in row and column flex direction mode, respectively. But if the preferred main size, so the preferred width or the preferred height, is also auto, then flex basis becomes content. I'm just seeing this fix me message here. I have definitely seen this fix me on my terminal, but let's see if we don't have to look into that now. Okay. Oh, wait, maybe this is what we have to look into now. Let's just see what we are. Okay, no, we're not printing that. I was thinking we're checking here for length, percentage, but we're not checking for calc. What if it's calc? We'll see. So I guess let's take a look at what the flex basis value is when we're here, because it's presumably not auto. Flex basis is toString. Is there no way to stringify that? Okay, so it has 3 modes: content, length, percentage, or auto. Sure. Let's just make a, let's just switch on it. Flex basis type. Okay, come on, Copilot. No? Sometimes Copilot is great at these things. Flex basis data. I already forgot what that thing was called. No, just flex basis. Okay. Auto. Maybe I don't even have Copilot running. No, I do have it running. Okay. Yeah, there we go. Well, it's pretty sweet. It's really good at this type of a task, I find. Like when you just want to print out a bunch of stuff, then very often it guesses what I want to type. But in this case, I guess I wanted to add those. All right. Well, that took a moment, but we are back on track. So we should see at least 4 of these pop up, 1 for each item. Seems like we're doing 2 layouts, fine, whatever. So they are auto, actually. That seems incorrect because flex basis is calc 50%. This is what we parsed, so, okay. Let's see then. So we think that it's auto. Why do we think that? because the computed values for the flex item says that it's auto. So we have clearly misassigned that somewhere. Set flex basis. What are we setting here? We're asking the computed style for its flex basis. So let's see, this is where we are extracting. We have a raw parsed CSS value basically, and then we're trying to turn that into a flex basis enum value. So if it's an identifier and the identifier is content, then it's flex basis content. If auto, then auto. If percentage, then we make a percentage. If it's length, we make a length. I wonder if we're ending up here. Oops. Seems like maybe we are ending up here and oopsing. Yeah, we're oopsing because these values are calc. So how do we do that? Is calculated, I guess. And then we have to make some kind of, what are we making here? Flex basis data. So this is going to be, what we want to do is we want to have a length percentage value because that's what the calc will resolve to if it's calc. So, but we'll store it as a length percentage because length percentage can hold a calculated value internally, which is then resolved at a later time. CSS calc is a bit annoying in that way because sometimes you have to wait until later before you have all the context required to resolve it to a final value. So here we are just going to make a flex basis length percentage as calculated. So I guess we have to wrap that into a length percentage. Can we do it that way? Maybe we can. Okay. Okay, so now we have length percentages instead of auto at least, but it's still looking the same way as it did before. So we wouldn't take this path. Instead, we would be down here where it checks if the type is length percentage and it is a percentage and the flex container has a definite main size. No, it does not have a definite main size. Oh, I see. So percentages are resolved against the flex container, right? So if you say flex item has a flex basis of 50%, then that would be like 50% of the width of the flex container. But if the width of the flex container is not known at this point, then we cannot resolve that percentage, right? So that's apparently when we fall back to content. I think this is just copied from the spec. So we're doing what the spec tells us. I think, at least. Is this from the spec? Yes, it is. Okay, good. In our case, though, we have a length percentage, which is calc. So it seems to me like we need to resolve that. Is now the time to resolve it? Or later, the used value. Because if it resolves to a percentage that we can't handle, then we have to make it into content. Okay, who calls this? Only this one caller, okay. So it calls this to get the used flex basis for an item. And then if it is definite, okay, so this is to determine if it's definite. We call this iffy here. Okay, so if it's not length percentage, return false. Ooh, well, look at that. Isn't that relevant? Handle calc. Relevant. Okay, so let me just triple double check that we are in the relevant section here. But it feels like we're gonna be. Hey, look, okay. So we have a calc value. What do we need to do? We need to figure out if, well, what we're really trying to answer is the value definite? So, the way we know that is if it falls through here, it would be a percentage, right? So these are all the non-percentage cases, auto length calc. So this is the, this is a percentage. This is not obvious, probably to somebody who's not familiar with this. At this point is a percentage value, so we could even verify that just to be double, triple sure. And actually, if we verify that, then we don't need the comment because that's exactly what this piece of code tells us. Okay. So I think here we need to resolve the calc value somehow. So let's get a reference to it. I'm a little bit unsure exactly how we handle these. I haven't written much code with the calc values. As calculated, that's not a thing. Calculated, okay. That gives us a non-null ref footer, so maybe I can even star that. Okay, and then if calc value resolves to a length, no, not result is length, resolves to length, then that's, I guess, definite at that point. That's at least that's what we say if it is, if we have a length here. So if this can resolve to a length, resolves to length. Do we have resolves to length percentage? No. Okay, well, let's see. What do we do later if it is definite? So we say true here, then later on it will try to just turn that into a value directly to CSS size. And this thing does not look at the calc value. Also, this is a hack helper. Cool. Okay. So if the calc value resolves to percentage, then these things here apply, right? So we can resolve a percentage if we have a definite width or height of the flex container, because percentages, that's what they are relative to. So I guess, but we could do something like let's do something like this. Bool can resolve percentages. Because these are not expensive accessors by any means, and this gives us a way to clean up the logic a little bit so that it's a bit more understandable. Can resolve percentages. Okay. All right. And then I think now we're going to start saying true, but it should still falls apart spectacularly, right? Oh, wait, does it fall apart exactly where? Percentage or? Say what? Okay, let's let me attach a debugger here just to see where we're crashing. That did not work super well. Sometimes debugger doesn't take, but this time it did. All right, so where are we? 646. 646. Okay, yeah. So we're here. We're calling toCSS size. That's the hack helper. Right, because it's not auto, it's not a length, and then we just assume it's a percentage, but actually it's a calc value. So if it is calculated, this is our time to resolve. Calculated? Does that work? Is that how we do that? Hey, look at that. It understands me. That's awesome. Okay, so now we just have to get rid of the debug statements that I added, which were not so many. And I like it. That's cool. Let's see if that also works on Shopify.com. Wow, so much debug spam here. We need to actually investigate some of those complaints. Okay, so that didn't quite pan out. Let's see what's going on here. 50% minus 3 rem. Wait, are those the ones? Okay, so it's not quite right. So let's see if, I think we need to get that CSS variable into the mix as well, just to be sure that, we're testing. Dun, dun, dun. Okay, so let's make sure that we have that CSS variable gutter or whatever thing that they had. Where is it? Here? Yeah, so 50% minus gutter, which is 1.5 rem. Okay, so gutter. Let's just put something like that here. Or maybe that was 3 rem, I guess, because then they divided it, or... Oh, no. Okay. Let's see that we're still doing this correctly. Okay. It feels like we're still setting that thing up. Okay. Wonder what else they have going on then. Are we missing something? Justify content flex start. We may need to bring over. I mean, we've already fixed one thing, but we may need to fix more things. Where's that thing? Where is that thing? Flex wrap, justify content center. Let's make sure that we have that. Oh, and they have a row gap as well. Let's, I guess, make sure we have that. Row gap, var gutter. Center. Column gap var gutter as well. Okay, so they have some things. Okay, so now we broke it. Let's see if that broke it in Firefox as well, though. All right. So we are back in business. Is it because of my border? Just have to double check. No. Okay, so what broke it? Was it justify content? justify content just centers it, which, I mean, that's the correct behavior if we end up on multiple lines like this. The problem is that we shouldn't be on multiple lines. Okay, so I'm just going to try to take things out until we have something minimal that still has the issue. Row gap, fine. So the column gap is creating a problem. Okay. And can the gutter just be like 10px? Don't have to use a rem unit. Do have to use a rem unit. Okay. Or do I though? Let me just put it like a big number here and see what happens. Okay, so it specifically doesn't work with 1.5 rem. Or 1.4. And I feel like it should fail with some pixel value as well. Yeah, it fails with 1px. What's the number I can use here? All right, so if the gutter is 1px, so if the column gap is 1px, 50% 1px. Wait, what does that mean? Column gap. So if the flex space is this 50% minus 1px, but there should only be the one gutter in between them. So you have two columns, 50% each, or 50% minus 1px. So it feels like this should add up and fit, but it doesn't. We might have some slightly wrong math somewhere. Cool. So, wonder where. I mean, this is probably going to be in the logic where we're figuring out if we need to wrap or not. So that would be in generate anonymous flex items. This is the function that goes through all the children of the flex container for each child of type. And then we figure out which of the children are actually flex items that participate in flex layout. So let's see. So we skip over anonymous text, like empty text we don't care about. Otherwise, you would get flex items for each of these white space sections here, for example. And we skip out of flow stuff like absolute position, children don't become flex items. And then we say, hey, you're a flex item. Okay. Oh, this isn't where we split into lines though. Into lines, collect flex items into flex lines. Here we go. And it's not a single line flex container because it has flex wrap. So we have this loop here where we go through all the flex items and we keep a running tally of how much we've spent on the current line, how much width, I guess, or how much size in the main flexing direction, which is the line main size. And then we see, can we fit another item? So we have the outer hypothetical main size that we base that on. Okay. And it has to be line main size plus the outer hypothetical main size of the current item. If that is greater than the available space for items, Then we make a new line. Right. Okay, so here, I guess let's just print it out. That's a very reasonable debug statement. Just needs a little bit of tweaking. Here we go. And we should also say how much we've spent already, I guess. So, what was it? Line main size. Line size. All right. What can we learn? Okay, so we have 0. Oh, I need to log. Need to log how much size total is available. Total available is available space for items, main 2 pixels. Okay. So yeah, this is what we're ending up with. We're breaking after every one of them. So we have 776 pixels available of width. We have here, so we have 0 so far. We add a 388 item and a 1 gap. So the next time we are at 389, and then we try to add 389 to 388, and it gets 777 instead of 776. Interesting. Why? Wait, why is this happening? I said that the size of those things should be 50% minus 1 pixel, right? So 50% is 388, but then there should be minus 1. Where's the minus 1 going? I feel like it's not listening to me. Flex spaces. Are you not listening to me? Why isn't the flex spaces 3? Where is it? Why isn't it 387? Okay, let's see. What if we tweak the flex spaces here? So we subtract like 10 pixels from 50%. Then what happens? So the available size is still the same, but now we have subtracted more from 50%. But wait, it still doesn't feel quite right. Flex spaces. Because 776 divided by 2 minus 10 should be 378, not 379. Why is it 379? That is weird. Okay. So who resolved that percentage, I wonder? Must have been when we calculated the outer hypothetical main size. So where did we calculate the hypothetical main size? Hypothetical main size. It's the item's flex base size clamped according to its used and min and max main sizes. Is this a clamping accident, I wonder? Can we get some help here? Maybe not. Hypo main. There we go. I wonder how the clamping is going. Hypermain is 377. That's weird. Clamp to -2, and I think that's infinity, or like it's the maximum size, which we print out this way for some reason. That's definitely not good. We should probably fix our floating point printer so numeric limits max doesn't show up as 0. But yeah, okay, so we have 377, clamping that, and then we add borders. So 1 pixel of border on both sides, so you get 379. 377. Where do we get 377 from, though? So it must have come from up here somewhere. We have a... I guess we are here. If the item has a definite use flex basis, that is the flex base size. So we must be here. I'm just going to see what this actually returns. A flex base size, da-da-da. So it becomes 377. Why though? 2 CSS size. Okay, wait, hold on. Let's do one step at a time here. It's nice that this browser engine is like fast enough to rebuild that I can actually printf debug it, because I was printf debugging WebKit, like 10 years ago, and sometimes you would wait many minutes for a rebuild, which was pretty tedious. So what are we looking at here? Say what now? Calc 50% plus 0 minus 10px. Okay, so I think this is like some of the canonicalization or whatever has happened to the calc value here. I think that's the spec tells us to canonicalize it that way. But how are we resolving that then? To CSS size, get pixel width for child box. So we're getting the containing block width for the box, and then resolving it. Oh, we have box sizing border box in effect, I guess. Oh, are we being screwed by border box here? Oh, is this a border box mishap? Oh, wait, no, hold on. Let me bring this back. Okay, so here's where it breaks. And then if we turn off border box, it's still busted. Okay. Okay, so it still comes out. The value is still bogus. $386. Okay. So what happens if I say 50% and don't do the -1 thing? 50%. The flex base size is 386. 50% minus 1px, 386. Well, that's definitely weird. So is there an off by 1 somewhere? Because after 1px, it starts caring. That is so weird. Does it not care about plus 1px either, I wonder? 387. 386 minus 1px. 386. What? That's really odd. Okay. Okay, so it feels like we have a problem with calc for some reason, that it's resolving wrong, I guess, for some values. How might that happen, I wonder? So where is that resolving itself? Resolve calculated. Okay, so this goes really deep. Oh my goodness. Okay, this is, what do we have? Trying to resolve. We're trying to resolve to a length. And we're trying to do a subtract, I guess. So this thing here feels like it's not really working. Or is it that plus a -1 is not working? So if you try to add or subtract internal. What are we looking at here? Number, frequency, length. Okay, so we have an add operation and a subtract operation here. Okay, so let's print out. I'm just gonna go in here and do some prints, because I have not really worked on this code, so this is how we explore. Okay, and I guess, oh, if it's a percentage basis. Percentage of, are we here? Percentage basis or something. I don't know. We'll see where we're ending up here. Percentage basis or something. Cool. And we're never adding anything together. It's always percentage basis or something. So I guess on the left-hand side, we have a percentage basis, and then we're adding that together with the right-hand side. Okay, so then we'll say, we'll do this, and then I will do like a little thing like that to indicate that we are under the percentage basis or something. Okay. Just to see what we can learn here. Okay, so adding 0 and 388. Okay. Maybe these should have been the other way around, but there's probably, we should write them the other way around. This px. Okay, so what happens if I add one to this guy then? I didn't need to rebuild maybe. Okay, so now it's adding -1 px. -2. Okay. So we're making some progress here. Okay, so we know that in the calc thing, this px is 1 off for some reason. What happens if I set it to 0? Just out of curiosity. Then it is 1. What? Okay. That is weird. So we had the dump of the style sheets. So it's telling us how we parse this. So, ooh, I wonder if we're screwing this up somehow, because this is not a px value, but this is. So it's like 0, the number 0, which would be here. Add sub CSS number. I don't know if we're even here. Let's just find out. No, we're not. Okay. So who makes that thing? How can I dump this out somehow? There's a dump thing. Okay, what's the high level dump function? Dump. Is there like a calculation node has a dump? I would love to see a dump of the calculation node. What is a calculation node and where does it start? Calculation result has a node in it. Cool. Calculated style value has a calculation node. Now we're talking. Calculation node A. Can I just get at that maybe? Please. Okay. And then I want to dump that out. We will even dump it out where we are. I'm gonna dump it out here. Good a place as any. Dump. I have to dump it into a string builder, apparently. Sure. Maybe we'll even do like one of those little things before and after, just so that we can tell where it starts and ends. I don't know what this is going to look like, but I imagine it might be interesting to see what's actually stored in there. I know Sam recently rewrote a bunch of the code for our internal representation of calc values. That is not a thing that exists, calculation. Oh, am I calling a function that's not implemented? Well, I'm terribly sorry. Or what? Dump. You had a second. Oh, just needed an indentation argument. Okay, so we were off to a strong start here, but it's getting a little bit more confusing. But that's what programming is all about. It's untangling the confusion. So let's see where this takes us. All right. What do we got here? So this is our calc value dump. We have numeric 50%. Well, we want to sum numeric 50%, negate numeric 1px. Okay. So what does negate do then? Feels like Mr. Negate might be a goofing things up. Negating the correctness of this whole operation. Oh, so that's where that comes from. It's just the way that it's printed. I thought that this represented some value. Negate calculation node, resolve, child value dot negate. Say what now? 1 minus? Sam. This doesn't seem right. That's not how we negate the number. That's not even how you print the thing. It says 0 minus in the printout, but all of these fellas here are 1 minus. But I mean, I'm just as much to blame because I reviewed it and I didn't think anything of it. So that's a little mistake we made there. But hey, look at that. All right. That's a funny bug though. Like just an off by 1 in the implementation of numeric negation. Pretty low level problem. And this was really good though, because it forced me to look around in the calc internals a little bit so that Sam is not the only person who understands how it works. So let's see if we can. Come on now. We are a 2x2 grid, finally. Cool. So that's excellent. Then we have to make some commits and tidy up, but this is awesome. And where do we start? I guess we're going to make commits and we're going to make tests as well, because nowadays we have layout tests for stuff like this so that we can protect ourselves against regressions and also just make it easier to work on layout in general by having a growing battery of tests that we can run to verify the correctness of changes. So I guess we'll start with should we start with the calc problem? Because it's kind of smaller in nature and we can kind of isolate it and make a simple test for that. Let me just clean up all of my debugging code here. And I don't need the dumper thinger. And somebody was texting me, but that's just Yella being excited about something, which I will learn about later. Let's see. So this thing here, we can just undo like that. Okay. Just checking that we're still on track here. Yeah, this is looking nice. Okay. And then I had a bunch of spam that I added, line size. That should do it, I think. Okay, so how do we dream up a test case for this? Calc, negate, negate length, let's say. So we will make a simple test page that has a foo, and then it will have a width of calc. I guess we can do exactly what we just did. So like something like, and then we will just mess that up because it will be off by 1, right? All of these are going to be off by 1. So container. So this should be 195 pixels, or just 95, let's say. Foo. Calc negate. So what does that tell us? It's 95 pixels wide. And while this would be enough for a layout test, because in layout tests we just compare the dumps of the layout tree, I always like to make the tests like a little bit more visual, just so that you can kind of at the very least, you can open them in 2 different browsers, and then you can do like a pixel for pixel comparison if you want to. If you make tests that are completely white, it is a little bit harder to visually intuit whether they are, in a good state or not. Which is where my favorite test colors, pink and orange, come in. If you have been watching this channel for a long time, you know that in the past I would favor magenta as the objectively best debugging color, but at some point I switched over to pink and orange. I think we need to give these fellas some height just so that we can actually see them. Okay, there we go. In this case, those are not the best colors because they're so close that it's kind of hard to see the edge of it. So let's instead say, what would be like, what if we make the foreground one green? It's I'm gonna make it look like a late 90s or early 2000s CSS test instead. So make the container red, and then we'll like subtract 1 pixel. Oh, but we should see the we're seeing the 1 pixel, which we should. These colors are silly. I don't know why why am I obsessing about the colors? Wheat is terrible. Orange and green, maybe. Black and green. Oh, that's kind of nice. Okay, so if we bring the bug back, so if we git stash, and then we open this thing in a broken version of Ladybird, then we don't see the black here. And if we dump out the layout tree, we see that it's 100 pixels. The foo is 100 pixels. So the -1px didn't work out. So we should see the line on the edge. So maybe green and black are cooler. Still obsessing about the color choices. But it's so hard to see the line. Maybe if I make the page background really dark. Oh, that's nice. Okay, yeah, so there should be a green edge to that fella. That means that we're passing. If there isn't the green edge, simply not passing. Okay. And then we can well, I don't have to write a description. You can visually see the difference, right, between the two. And let me just remove the trailing new line at the end. Okay, then we have a nice simple test. And we bring in the fix and calc negate length. I'll put that in tests, libweb, layout, and put this is, I will just put it there for now, maybe. Okay, and then I have a script that I run to just create the file with the output. We could also do that with headless browser -d like that, and just arrow it into the right location, which is there. Or wait, did that even? Yeah, it looked good. Okay, but this has the incorrect result though, so we need to actually rebuild first. Now it has the correct size, so git add web fix off by 1 in calc css calc negate operation. Negating, when negating a number, we should subtract it from 0, not 1. All right. And then this was the flex basis calc, which we can use this test that we made. So I will put that in tests, libweb, layout, flex, input flex, and calc flex basis. I guess it's not the worst name for a thing. And we can create an expectation. Then we will add them. Although I think the expectation now that I made it's going to be like a little bit, it's like a little bit extra white space and stuff in that. So I like to clean those up usually. Just because it makes it easier to see what the test is about. So I just remove the white space between elements and the trailing white space at the end of the file. And here you can see what actually disappears from the layout tree when we do that. So because whitespace has layout significance in CSS, we're forced to create anonymous block containers for holding whitespace everywhere in the page, which is annoying, but that's just how it is. If you don't do it, you will break layout somewhere eventually. So it is what it is. But we don't have to pollute our test with it when we can avoid it. So there we go. libweb, support calc values. Support flex basis calc. This, I mean, there isn't really anything super exciting about the change itself. It's just taking care of that fix me and making sure that calculated values actually propagate all the way from style properties into the flex formatting context. It's pretty straightforward. This is pretty straightforward, and the main issue was that we weren't even, or no. Let's see. Propagate, calculate calc values from style properties to computed values. Actually resolve calc values when determining the used flex basis. Yeah. This makes, no, I don't have to. I was gonna explain what web page. Oh, you know what? It's fun to say things like that, actually. This makes the support section on Shopify.com show up as a 2x2 grid instead of a 1x4 grid. All right. Maybe I should mention correctly show up. Show up correctly as a. Okay, there we go. Excellent. So, this was very productive. Let me see. So now we have to check that we didn't actually break tests. So ctest layout. No, wait, is it capital R? Yes. I did break something. What did I break? Oh, I should have used output on failure. Calc flex basis. Wait, what? Oh, did I just not rebase that after I... Looks correct. Maybe it's one of those things where I have to say, I think maybe if I say the font explicitly, yeah, this doesn't always work correctly with automatic font selection. So I've found that sometimes you have to be specific about specific font in layout tests, or you can get inconsistent metrics. And now I got got a new line at the end again. Okay. That's fine. C-test. Let's make sure that we can run all the tests. So now we're just running all the layout tests we have, which we keep accumulating more of them. Ooh, something broke. How did it break? What on earth? Grid gap 2. I guess, could I have interfered with, look, it has calc. So I should have rerun the tests after the calc change, of course. Let's see. So that let's see, rebase test. So it just has like slightly different metrics because the negation is slightly different, right? Yeah, 10% minus 10px. Interesting. So you get 9px instead. Or, well, whatever. Let's keep going. So let's just see if we're breaking many tests. I should probably have some helper commands for things like re-baseline all the tests and then show me like a diff of everything that changed. Because right now the test runner stops after every failure, which is kind of irritating. Now we keep failing on this test, even though I've updated the expectation. That's a little bit strange. Is this a font thing as well? Or what is happening here? Okay. I don't know why I needed to change the font there. That was very suspicious. More calc stuff. Cool. Let's see. Can we just re-baseline that? Okay, I don't know. Something is definitely afoot with that. So why do I have to insert the font manually? I'm not supposed to need to do that. So something is afoot with that. I don't think we have a lot of calc tests in general. So I'll just do these as a fix-up. Actually, for the previous patch right there. Okay, I think we're good. So this will be the end of today's video. If you made it this far, then I thank you for watching, for hanging out, and I hope that you saw something interesting here. This was basically a very accurate look of how I've been spending my days lately, just fixing random layout problems one by one, just grinding through, trying to make progress on just doing a better job of rendering the web, basically. And we are making great progress, and performance is improving as well. As you can see, paint performance is getting pretty good, and this is still a very naive painting architecture, so that's positive. Recently did some work on resize performance. Of course, it doesn't look particularly impressive here because it's a very complex page, but rest assured, in the past you would have had to wait much longer before you saw visual changes when resizing. But yeah, this will be the end of the video. So it's good to be back, and I'll see you all next time. Bye.